Welcome back. So we will start our part B. So in that part B, we have a series of experiments. We did in lab. In lab, we have done this half-adder using this schematic. If you see the syllabus, we have this basic logic gates inverter, NAND, NOR. So this also will be asked in exam, okay? You might have to design inverter because we did in lab half adder means when you have done half adder, these are more easier than this half adder. So a person when he or she could able to do half adder, they must able to do this inverter and NOR also. So watch this carefully how we are going to do this one. So let's go to this explanation. Here, when in CMOS, that is in CMOS, complementary metal oxide semiconductor, there are students who are not familiar with full form as well. So please pay attention. This is a complementary metal oxide semiconductor. Here, to design this inverter, what we have to do is, so we have to use one PMOS device. This is how you represent PMOS device, and one NMOS device. This is how you represent NMOS device. This is gate. You connect this gate with this gate of NMOS. And connect the drain. This is the drain of this PMOS. Connect with this drain. And take output from here, where you are connecting the drain of this PMOS and the drain of this NMOS. From there, you are going to take the output. So let's call this output as Y. And here you are going to connect your VDD. And here you are going to connect your ground. So your ground will be here. So as PMOS, this PMOS is a 4-terminal device. Here you have the bulk, that is body terminal or bulk terminal. And this NMOS also has got a body terminal. So the body terminal of this PMOS will be connected to the source here. This is the source. And the body terminal of NMOS will be connected to the source of this NMOS. Okay. So here is your input. This is your input A. So now what is your output Y? Y will be A bar. So that's how the circuit is going to behave. So let's see now in LTSpice how we are implementing this one. So once you have installed your LTSpice, so you will see this icon on your desktop. So double click that. So you will have this kind of interface. So when you have this kind of interface, you have to click on this icon. This is for new schematic, or you have to click here, file, and then use. So both is possible. So now here you can start placing the components. To place the components here, you go to this toolbar here, component, and then you try to pick here where your PMOS is. Here you have PMOS, which is a 3-terminal device, and this PMOS is a 4-terminal device. Okay, you take this PMOS 4-terminal device, then click OK and place it here. Now we have to take NMOS, again click on this component and take NMOS 4, that is 4-terminal device. Click on OK, then place under this straight here. Okay, so now we have to make a connection between this the way we discussed here. So to connect here, we have to take this wire here. This is the pencil icon. That is for wire. Click on that, and you'll get this kind of representation of this wire. So place here, and then left click, and then simply you hover your mouse. You don't need to drag it. You have to simply hover your mouse. Come to this point, click there, left click. So connection established. Now we also have to connect these gates. And let's say you wanted to take, a turn from this point here. So there, once you click, then come down here, just hover your mouse there. Then from this point, you wanted to move this direction. There you click once, then you take a direct diversion like this, then click here. So that way you establish the connection. Now you take here this from source, little wire here, just click there and then right click. So you are leaving little wire, extended wire there. Here also, you have to leave the extended wire. Okay. Now you also take the extended wire from here, left click and then right click. Then here, left click, hover your mouse. There you left click, then right. So that way, you are placing your wire connection there. Now, this is your body terminal, this one. So there, what you have to do is click there and just move this side. Click there again, go up, click there again, then hover your mouse here, then click here. Connection established. Same thing here also for NMOS. Take this wire there, click there, come down here, and then click there, and then move this side, and then click. So you have done with all connections. Now what you have to do is, you have to go to this label net, click there. Let's name this input as A or V in. So V in. And here, do not pick anything like if your port type, input, output, bidirectional are there. Don't touch them. Just none. Okay. Now click OK. So this one, you just place it here on the wire, then click. Now you can click this one. You can place this one everywhere here. Later you can edit. So place it here for VDD and place it for V out here. Now here, right click. Just go your mouse cursor, take there on that label, right click. Now you can edit. So edit as a VDD and then click OK. This also you can do the same. Place your mouse cursor on this label, right click, and then edit. That is V out. Now click OK. So now this here we have to place the ground. So for ground, you have this, and then come here and place here. Then click. Now what is required is you have to take voltage sources, right? So you have to apply input here. So, and you also have to apply VDD. So for that, voltage source is required. Go to component. Here, voltage source will be there. Click this and click OK. Now we need two voltage sources. One for VDD, one for Vin. So this is for VDD and this is for Vin. Now same thing again. Take the wire and little extend up here and little down here. And same thing for this also, little up here and little down here. Now, again, this label, just VDD, click OK and place it here. Okay. So that way, what is that we are doing is we are establishing connection. To see the full view, click this one here, zoom full extends. Now you can see the complete view of this schematic. So if you use label net, you can avoid using wires running from all over from this point to this point like this. Okay. Like this you can avoid. So if you use VDD, as if you have used this wire, like that it is. To delete this wire, click this scissor cut and place here and then click and then here. So that way what you have done is you have removed that. Okay. Now take this ground, place it here and one more here. So here just to move this one little bit this side, go to this move and select this entire area like this and then move here little. Okay. Now this instead of taking wire from here to here, we take this label and we call it as a V in same name where we want to establish the connection. So V. So now there is a connection between this V in here till this. Okay. Now we have to assign the value. So place here, right click. Now 5 volts. That is simplify. Don't give the V. Simplify. Click OK. This is for VDD. Now here, come here. See the mouse cursor how it is changing. Right click. Go to advanced. Go to pulse. So now pulse height is like 5 volts. And then leave this delay, rise and fall. So come to the on here. On period, I wanted to keep for 5 nanoseconds. 5N you give because S is already here. We don't need to give S. Just 5N. 5N means 5 nanoseconds. And the period of that pulse is 10 nanoseconds. 10N. Okay. Click OK. So now what we have done here is this overlap is not a problem, but still if it is looking differently, then you just click this one, that is move. Click over that and move. Hover your mouse. You don't need to drag. You have to hover your mouse like that. Okay. So now all connections are done. So now what you have to do to save this one, you go to file. Now go to here, save as. As I told, in one folder you have to work. So on desktop, I have created this one folder here. That is this lab demos. So I'm selecting that. Don't put here directly. Don't save here. All files will spread over here. Inside this folder, create another folder. Name it as a inverter. Okay. Inverter. Select that folder. Now name it, this file name properly you name. That is inverter. Inverter. Schematic extension already taken here. You don't need to give here extension. Just simply select that folder. Just we created inverter, right? This folder, select that and click open, then save. Now what you have to do, you have to run. So click on this run button. It will prompt like this. This is the transient analysis that we are doing. Don't go to this AC, DC, noise, DC transfer, DC operating point. So just transient here. By default, it will come on transient only. So the stop time here it is, let's say we wanted to run till 100 nanoseconds. So 100 N you have to give. That's all. That is the only thing that you have to do. Click OK. Now it will show up like this. If you want to see side by this windows, so you can take like click on window and tile vertically. So side by it will come. Now select what is that you wanted to print here. So I wanted to print my V in. You can go here or here, no problem, because they are connected. That is one thing. The other thing is, observe carefully. Mouse cursor is, this is the shape of the mouse cursor now. The moment when I take here, this is one shape. The other shape is this one. This shape is for current. If you wanted to measure some current, then this shape, it should come. Then you have to click. But I don't want to measure the current there. I want voltage. So this is the shape. When this shape is taken, click. And then come to the output. Like that. So now they've been overlapped. That is input and output. So what you have to do here is, you have to right click there, add plot pane. Now here you have to drag holding this one. So I wanted to keep here. This V in. So hold this, left click, hold it and drag here, leave it like that. So now you can see here, if you want a cursor here, you just click here this way. The moment when shape being changed like this, click there, left click. Now you can see this cursor has come here. This one you can keep here anywhere. Now you can see here when this is 1, your output is 0. Okay. So this is inverted. So this is 1, this is 0. You can see the pulses here. This is high and this is 0. So like that, uh, this is the inverter experiment. Okay. We have done the inverter experiment. Okay. Now we will go to the same video. Let me see that. We will take another video for NAND. Okay. We will stop this one here. So kindly practice the way shown. You please watch this, stop this, pause the video, watch it carefully, do it. If you do, then you will gain the confidence. If you fast forward and if you do not practice, then you will not perform in external paper, I'm telling. Okay. All the best. Stopping my recording.